Good afternoon, everyone. My name is Calinawan, and I will be giving you an intro to WebAssembly. Before I start, I just want to give a shout out to Lynn Clark. They make excellent cartoons for on coding, and this one I particularly relied heavily on, called A Cartoon Intro to WebAssembly. Okay, so in June 2015, Brendan Eich, who as you all know is the creator of JavaScript, wrote on his blog that there's going to be the advent of a new thing called WebAssembly. And since then, it has been nonstop in the news with titles such as What is WebAssembly? The Dawn of a New Era, WebAssembly finally freed from JavaScript, and as of this month, WebAssembly is actually now ready for browsers to use. It has been a cross-browser project, and it's now going to be default in Firefox and Chrome by the end of the month. So here's an actual quote from Brendan Eich's blog. "It is by now a cliche that JavaScript has become the assembly language of the web. Today I'm pleased to announce that cross-browser work has begun on WebAssembly, a new intermediate representation for safe code on the web." If you're like me, you would read this and be like, cool, but what? Like, what is an assembly language and what is an immediate representation? We're learning JavaScript, but we don't know it as an assembly language. So here is Lynn Clark's depiction of what an assembly language is. It's that add R1, R2. It's the symbolic representation of the machine code. And of course, since there are different hardwares, there's going to be different assembly dialects. So you would write in a higher level language like that, you see C, C++, Rust, and they'll subsequently be translated to the assembly dialects. As you can see, this isn't a particularly efficient way of doing this. So most compilers have an intermediate level of they have like a first step of translation called an immediate representation, and that's what subsequently gets translated to your assembly dialect. So where does WebAssembly fit into here? Well, WebAssembly is another compile target that eventually gets compiled right into machine code. It's not as high level as C, C++, or Rust, and it's even lower level than the standard immediate representations. It's much, much closer to your machine code. And so how can WebAssembly improve upon the performance of JavaScript in particular? We're talking about compilation, but I want to talk a little bit about transpilation. What happens now is that you can code in a different language and it gets transpiled into JavaScript. The problem is that JavaScript isn't actually that good at being transpiled to, in part because it is of dynamic typing, and that's like something that if you've written in other languages, you know can be is very different with respect to JavaScript. So in response to that, there was the development of asm.js, which is a statically typed version of JavaScript that's much easier for other languages to compile to. And WebAssembly is sort of a continuation of that process. So how is WebAssembly an improvement upon the performance of JavaScript? Real quick, I want to talk about how JavaScript performs as quickly as it does today. When JavaScript was first made in 1995, it wasn't very fast. It wasn't really meant to be fast, I think. And then in 2008, there was the advent of just-in-time compilers. And the just-in-time compilers really picked up the speed. You can see in 2017, Lynn Clark is anticipating that there's going to be another shift upwards with the advent of WebAssembly. So real quick, let's talk about how just-in-time compilers work. There's a difference between interpreting and compiling. Interpreting is when you translate something line by line by line, whereas compiling is when you take an entire document, you read it, and then you translate it. The pros and cons of this are very obvious. Interpreting, it goes much faster because you don't need to wait for an entire finished product to be handed to you. Whereas interpreters, though, have to, let's say you're going through a loop, it's going to have to read that loop over and over and over again. It's going to say this line, then this line, then this line, and even if it's already done it, it's going to do it again. So just-in-time compilers are kind of a combination of both. What it's going to do is it's going to have a very quick startup, but if they're starting to see that a pattern is getting repeated, it starts to optimize and compile that pattern. But then, so here's an example of that. Instead of asking over and over and over again, is this of a particular type, it's going to start making assumptions about the code based on how it's been running. But then what happens when the assumptions are wrong? Then it's going to go through a process called de-optimization, where it throws out what it optimized before. So this is how JavaScript is interpreted, or this is how JavaScript runs. First it's parsed, then it's compiled and optimized. It's re-optimized and de-optimized. Then it executes, and then there's garbage collection. Whereas you can imagine a much lower level language, rather than parsing, is decoded, compiled and optimized, and then just executed. There's no garbage collection, there's no process of re-optimization, and that really cuts down on the time. In addition to that, the WebAssembly code is really close to bytecode, so the file itself is much smaller, and like even just the fact of serving up the file is a lot faster. So now we're going to do a demo. This is a demo game that was written in that was compiled to WebAssembly, and it's just like really impressive. Like the graphics are amazing. There's a part where there's rain. I'm very impressed by rain. I don't really play video games, but my husband does, and he says that this is like impressive for a browser game. Can anybody speak to that? I don't know. I really want to find this rain for you guys, but I won't. Yeah, so it's like just a really impressive what you can do. And then finally, on a final note, WebAssembly will change the world. I have lived in the Philippines for the last 3 years, and I paid as much in the Philippines as I do for internet for something that was 1/10 the speed of what you get at the local subway station here. Like, I think that if we can find something that can speed up the process of the internet, I don't know what it can do for places that already have infrastructure like New York City. I can't anticipate that. But at the end of the day, if we have something that can speed up the internet, I think, or like other people's experience of the internet, I think it's going to make the internet what it should be, which is a place of equal access and distribution across the world. Thank you.